Welcome back. And in the last video, we saw how to create a confusion matrix with Seaborn's heat map function. But right now, our confusion matrix using Seaborn is not really offering much. Like, it's blank. I'm better off using crosstab up here. But if we wanted to make it a bit more visual, what we might do is add some information to this and functionize it. Because if we want to plot multiple confusion matrix, it's good to have it in a function. So let's make it plot confmat. And we'll pass it a confusion matrix with the variable name confmat. And then we'll put in a little doc string. Remember, we want to be great communicators here. Plot a confusion matrix using Seaborn's heat map. Something nice and simple. Again, we could upgrade this to say what actual confusion matrix is, but it's kind of intuitive. Anyway, fig ax. I want to set up a plot plt subplots. We want fig size. We'll go 3 by 3. Ax equals sns dot heat map. We've seen this. We're going to pass it confmat. And then this is where we can add some information. So we want a not, short for annotate, equals true. We want to go here. This is a comment. Annotate the boxes with confmat info. Beautiful. And then we want a cbar equals false. Now these are parameters of the heat map function. You can see those in the documentation here, seaborn.heatmap, or as always, by pressing Shift Tab there. Wonderful. And then we're going to add some communication. So plt.xlabel is going to be the true label. And then plt.ylabel is going to be the predicted label. Wonderful. Put a little semicolon there. And then we'll call plot confmat. How does this look? All right, we're getting some communication. We're getting somewhere, but why are our numbers appearing literally off the grid? Well, how would you figure this out? If you ran into this sort of problem, what would you do? Well, I'll tell you what I did. I went like this. I went Seaborn numbers not appearing in square on heat map. Something like that. There we go. SNS heat map top and bottom boxes are cut off. Now this is one of the GitHub issues. With Seaborn, let's zoom in a little bit. With Seaborn 0.9.0 and Matplotlib 3.1.1, the topmost and bottommost row of boxes in Seaborn plot are cut off. Ah, yes, 0 is getting cut off there. So this is a big version of heat map, and so theirs is getting cut off just like ours. I see. All right, what can we do? This was a Matplotlib regression introduced in 3.1, which has been fixed in 3.1.2, still forthcoming. Okay, for now the fix is to downgrade Matplotlib to a prior version. All right, so there's a few fixes here, and so what I've done, we're not going to go through it all, but essentially that's the process I took, right? Was I just searched the error that I had, and then you come across resources like this and you read through them and you go, okay, there's some potential fixes. This might be my issue. In my case, my issue is that I'm using Matplotlib 3.1.1. But after a little bit more digging, I found a workaround that you can do without having to downgrade Matplotlib or wait for the update to come through. And that's fix the broken annotations. This happened in Matplotlib 3.1.1. By the time you try out this, right, this function may work perfectly for you because you'd be using Matplotlib 3.1.2 where the error gets fixed. But if not, this is a workaround, right? And that's what we are as engineers. We're looking for solutions to our problems. Not necessarily workarounds, but solutions to our problems. So this is ylim. So this is going to say bottom top ax equals get y limitations. So we're getting the limitations of our y-axis here. And then we're going to go ax.set ylim. We're going to go bottom plus 0.5 and then top minus 0.5. We can take out the semicolon here, put it here. So what is this doing? First of all, let's see it. Wonderful. So this is just saying, hey, set bottom and top to the current y limitations of our axes, and then reset them to be bottom plus 0.5, so it's going to move that number up. If we go comment out this, it's going to move that number up, and then it's going to bring this number down, or these two numbers down. So that's all that's happening in these two lines. And that was a fix, again, I found through a little bit of searching up something like that. Seaborn heat map plot numbers not appearing in the right way. Now, that's looking a bit more like what we used in our confusion matrix anatomy. Beautiful. And now that's looking like exactly something that you can start to share. You could even start to try and customize these labels here so that someone knows what 0 is, or put a little key here. So 0 is not heart disease, 1 is heart disease. You could customize this as much as you want, but that's essentially one of the best ways to visualize a confusion matrix. Now you might be asking is, why did we jump straight to Seaborn instead of using Scikit Learn? Surely they have a plotting a confusion matrix. And I thought the same thing too. But if we look at this, if we go from sklearn.metrics, import plot confusion matrix, then we go plot confusion matrix, pass it our CLF. So if we look at this, cannot import name plot confusion matrix from Scikit-learn. Why is that? So if we go here, Scikit-learn, plot confusion matrix, okay. And then we go down here. How's this happening? So from sklearn.metrics, import plot confusion matrix, okay. And we see that they've used the function here. Now we click on this, sklearn.metrics plot confusion matrix. All right. So that's what we've done, right? We've imported it from here, from sklearn.metrics import plot confusion matrix. Yet it still doesn't work. This is one of the caveats of using an open source library, right? Is that although Scikit-learn is incredibly helpful in offering us a bunch of different functions, and same goes for any other open source library, there are some cases where certain functions may not work, right? Like this. We try to import it, it doesn't work. So again, this is another example of where we've created a solution to our problem. If we couldn't use Scikit-learn's metrics function, plot confusion matrix, we build our own. We use Seaborn's heat map, or we could even just use Panda's crosstab. This is a prime example of putting on our engineering hat and figuring things out. But in essence, the main thing to remember with the confusion matrix is it shows you where your model is getting confused. If we go back to our anatomy, the correct predictions are going to be along the diagonal, and the false negatives and false positives are going to be on either side of that diagonal. So, with that being said, we've covered a fair few things with the confusion matrix. Let's have a look at one final classification metric, which is also really important, and that is called the classification report. And we'll change this into Markdown, and we'll finish the video there. I'll see you in the next one.